Hey yo, 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 yo. Screw Diaz here. We're going to talk about proportional and non-proportional relationships again. I feel like we've already talked about this stuff, but we're going to keep talking about it. So we're going to distinguish between proportional and non-proportional relationships. So these are some definitions that we might already actually know, but it's good review because these are also such important key terms. So proportional, we know it's a constant rate, begins at the origin. Non-proportional, could be a constant rate, could not be a constant rate, but it doesn't begin at the origin. So non-proportional could be a straight line, but then it doesn't start at the origin. So let's say this is my awful XY axis right here. That's supposed to be a straight line, not very good. But it doesn't start at the origin, so it's non-proportional. Non-proportional also means it's not a straight line. So I could start at the origin, but I could be a curve. And then if I'm a curve that starts at the origin, then it's not a straight line. It's not proportional. Slope-intercept form, y equals mx plus b. Anything in slope-intercept form is a linear equation, which means it makes a straight line. And linear means something that makes a straight line. So here we go. So all we're doing is we're just looking at these certain scenarios. I'm going to make this a little bit bigger for you guys. Looking at different scenarios, and we're talking about whether or not they make a proportional relationship or not. So this shows the sales tax charge based on the amount spent at a video game store. So right away we notice that it is a constant rate of change because it makes a straight line. It is linear. Okay, so does the graph show a linear relationship? So yes, it is linear. Because it's a straight line. That means it's automatically linear. Then we have to ask, is it proportional or non-proportional? And the answer is yes, it is proportional because it's a straight line that goes through the origin. Now, because it's a proportional relationship and it is linear, that means the equation would be in the form of y equals just m times x. There is not going to be this plus or minus b here. This is 0. And we ever add 0 to anything, we don't need it. So that's why it's just going to be y equals whatever my slope is times x. We've also looked at this value as k as well for that constant of proportionality, because proportional relationships, that constant of proportionality did represent the slope. So you could look at that as well. And if I wanted to find the slope, I could. There's a perfect point, up 1.2 over 20. And I can simplify that. Okay, but it is linear and it is proportional. Sometimes you're going to be given an equation. You have to determine if it's linear or if it's proportional. So the number of years since Keith graduated from middle school can be represented by the equation y equals a minus 14, where y is the number of years and a is his age. Is the relationship between the number of years since Keith graduated and his age proportional or non-proportional? So I did not mean to do a little mark there that makes that an equal sign. Whoops. So whenever it's proportional, we're in the format y equals m times x, or also when we first learned about it about a month ago, it was y equals kx, because this was that constant of proportionality. Is this in that format? And I hope we say no because of this minus sign right here. This minus 14, this doesn't have a minus sign on it. It doesn't have a plus sign on it. Okay? None of that's allowed. It can't have any of that. So therefore, it's automatically not proportional. Now, if I asked you if it was linear, well, it is in the format y equals mx plus b. So the plus b could also be a minus b, right? That just means it's negative instead of positive, so that works. And then it would be m would just be 1 here, and then there's that x. So it would be linear. Even though we're not asked about that, it would be a linear relationship because this is just saying if I have 1 times something, it's just that something. So the slope is just 1 on this one. Okay, so this one right here, determine if each of the following graph represents proportional or non-proportional relationship. Well, we know that they both represent linear relationships, which is nice. They're both straight lines, so that means they're both linear. They both have a constant rate of change, which is great. So that means I know both equations can be written as y equals mx plus b. Okay, and I know that wasn't asked, but it's still important to note that they're both linear, which means they both can be written as y equals mx plus b. This one, not proportional. Doesn't go to the origin. Starts up here. So that means the y-intercept isn't 0. This y-intercept is 1. So we know it'd be y equals mx and then plus 1 because the y-intercept was moved up. Not proportional, still linear, still changes at a constant rate. And then I can figure out my slope to figure out what this m is. This one over here is proportional. It's a straight line and it starts at the origin. So now we know it's just y equals mx because this b is 0. We don't need it then. So this one is proportional. And that's it. So remember, you can be proportional or non-proportional whether or not you are linear. Okay, so it's just making sure it's a straight line that goes through the origin to determine if it's proportional or not. So now looking at equations, we should be able to determine if things are proportional, if they're not proportional. So go ahead and give those independent practice problems a shot, and then we'll talk in the next time I see you guys. All right, thanks for watching. If you have any questions, let me know. Good Diaz out.